Howdy, today from Science, we're looking at esters. So science understands we're going to look at carboxylic acids undergo condensation reactions with alcohol to form esters. So here's that condensation reactions understanding again. So you need to identify, name and draw methyl and ethyl esters containing up to 8 carbons with up to 2 side chains. Draw esters produced by condensation reactions between carboxylic acids and alcohols given their formulae. Draw structural formulae of polyesters and identify products of acidic and basic hydrolysis of esters. So esters contain this functional group here. So it's made up of a part that comes from a carboxylic acid and a part that comes from an alcohol. Why are esters important? Well, they have a nice fruity odor a lot of the time. They are added to foods and to perfumes to give them nice odors. The way that they're produced is you react the carboxylic acid with the alcohol under reflux using a small amount of concentrated sulfuric acid as a catalyst. So the reaction that produces an ester is called esterification. And here's an example using basic formula of what's going to happen. So you have your carboxylic acid, the R1 here, that's your carbon chain, that's part of the carboxylic acid. That reacts with the alcohol, R2, that's the carbon chain from the alcohol. You react them together under reflux, so you're heating them constantly and with a trace of acid, so that's where that hydrogen plus there is. And that produces your ester, so we've got the R1 from the carboxylic acid and the R2 from the alcohol, and also water. So this is a condensation reaction, it gives off water. So let's look at an example. So the carboxylic acid that I'm going to use is this one here. So methyl ethyl propyl butane, so this is butanoic acid. So we can see the carboxylic acid group here, C double bond O, and the OH bit. So butanoic acid, we're going to react that with ethanol. So here's ethanol, so 2 carbons, and here's our hydroxyl group. So they're going to react together. When they react together, they produce this ester here. So you can see the ester group here. We've got the C double bond O and the oxygen down here, and give off water as well as your other product. Like I said, this is a condensation reaction. We'll look at naming, and we'll name this one in a second. So to name an ester, you look at the alcohol and you look at the carboxylic acid that make up the ester. So the first part of the name we put "il" at the end, and that comes from the alcohol. The second part of the name comes from the carboxylic acid, and we put "-08" at the end. So here's an example. We'll look at this one here. So the first bit you do is you look at the part that comes from the alcohol, and that's attached directly to the oxygen. So they've got 4 carbons here, methyl ethyl propyl butyl, so this would be butanol, would be the alcohol that produced it. So the first part of the name would be butyl. Okay. Then we look at the carboxylic acid bit. There's 3 carbons there, so methyl ethyl propan. So it'd be butyl propan O8. So butyl propan O8. That's how you figure out the name. The way that I remember it is the alcohol parts. Alcohol makes you ill, so that's how I remember. So the alcohol part here, ill. So methyl ethyl propyl butyl, methyl ethyl propan O8. So butyl propan O8. So if we look at the example that we just made, so the ester that we just made, we look at the part that comes from the alcohol. So 2 there, so that would be ethyl for the ethanol that produced it, methyl ethyl propane butane, so we've got butanoate again. So this would be ethyl butanoate. So let's talk about polyester. Polyester is a plastic. So here's some examples of some polyester plastic over here. We're going to talk about polymers in a little bit more detail later on, but the idea is you have lots of the same groups joined together. So lots of compounds of the same groups repeating themselves over and over again. Poly means many, ester means esters, so many ester groups joining together to make up polyester. So this is the ester group here that we've been looking at. So in a polyester you have lots of those repeating units over and over and over again. You can make polyesters in a few different ways. One way is by using a diol and a dicarboxylic acid. So the carboxylic acid from the dicarboxylic acid and one of the alcohol groups from the diol react together, and then the other ends can add on to other ones, and so on and so on and so on. So let's have a look at that. So here I have two images showing how PET is produced, polyethylene terephthalate. This is the plastic that Coke bottles are made out of. So here you have ethylene glycol, which is your diol. You have terephthalic acid, which is your dicarboxylic acid. They react together and you get the repeating unit forming. And when that happens, every single time you do that, you get a water molecule coming out. And that's why this is a condensation reaction, because you get that water molecule coming out. So the diol and the dicarboxylic acid reacts. The alcohol reacts with the carboxylic acid group. That produces the ester group, and then you get that repeating and repeating over and over and over again. The other way you can make a polyester is by using a hydroxycarboxylic acid. So what that means is hydroxy is OH, that's the alcohol group, the hydroxyl group, and then you've got a carboxylic acid group on the same molecule. So you've got a hydroxyl group and a carboxylic acid group, so that makes it hydroxycarboxylic acid. And they will react together to form your polymer. So here we have lactic acid. So this is lactic acid, and we're making polylactic acid. So lactic acid molecules have an alcohol group at one end and a carboxylic acid group at the other. You can react those together and you get polylactic acid. And remember, every single time you do this, you get a water molecule coming out because it is a condensation reaction. Once you've made an ester, you can break it up again, and that process is called hydrolysis. It's called hydrolysis. Hydro means water, lysis means breaking. So we're breaking it up using water. And there's two different ways you can do it. You can do it using an acid, or you can do it using a base. We're going to look at using an acid first. So in acidic conditions, when you hydrolyze the ester, you get the acid and the alcohol back. So here's our example here. So we've got methyl ethanoate, so methyl ethanoate, which is known as methyl acetate as well. So we're reacting that. This is the water here, so that's the hydrolysis part, the hydro bit of the hydrolysis. So water with our ester, we're using an acid here, a strong acid to do this. That produces our carboxylic acid and our alcohol. So our alcohol, so that's methyl, this bit here. So we get methanol back, and ethanoate, so ethanoic acid. So here's ethanoic acid here from the ethanoate bit from this part of the ester. So in acidic conditions, you return back to what you would have started with. This is a reversible reaction. So when we're making the ester, essentially we're pushing it in this direction, and if we hydrolyze it, we can push it back in the other direction. So if we're going to hydrolyze our ethyl butanoate, we're going to react that, we're going to add in water. So water with our ester, strong acid, we're going to get back to our carboxylic acid and our ethanol. So water plus the ester goes to the carboxylic acid and the alcohol in acidic conditions. When you do hydrolysis under basic conditions, you don't get the carboxylic acid back directly, you get a carboxylate salt. So you get that, but you do get the alcohol back. If you want to get the carboxylic acid back from the carboxylate salt, once you've done the reaction, you then add a strong acid to the carboxylate salt, and that will reform the acid, and you'd get another salt. You'd get another salt as the other product there. So here's our example down here. So we've got methyl ethanoate again. This time we're reacting it with sodium hydroxide. That's our base. We're breaking it up. We're getting our salt here. So our salt there would be sodium ethanoate. So 2 carbons there. So sodium ion here. So sodium ethanoate, and the alcohol, so methanol, and that's what we get back. So let's have a look with our example. So our ethyl butanoate. So now we're reacting with sodium hydroxide. Now sodium hydroxide doesn't look how I'm going to show you what it looks like. I'm using a little blue ball to represent sodium, and I've got my OH bit here for hydroxide. It's not like this at all. In fact, what it would be is something like this. You have the hydroxide ion with a negative charge sticking to the sodium ion. So that's what it would look like. So if I have that there representing my sodium hydroxide, we react that together, we get our ethanol back. So we've got our ethanol from this part of the ester, and then we get a carboxylate salt. So here's the carboxylic acid, so this is our methylethylpropylbutanoic acid. So what would happen here is, I'll take my sodium ion from up here, we'll break off the hydrogen ion from down here, and we would get these two sticking together. So the oxygen has a negative charge here, the sodium has a positive charge, so they would stick together. So that would be your sodium butanoate. That would be the salt being produced. So like I said, if you wanted to make the carboxylic acid again, you just react this with a strong acid, and you would get back to the carboxylate salt. So that's looking at esters, so how to name esters, how to produce esters, and their hydrolysis. That's it for Flipping Science today. See ya.